down, I'll just carry on talking. Are you ready? Yeah? I'm waiting for a sign.
You are sponsored by Acer.
By who? Acer?
Acer.
Acer. Oh. No, get the Acer off me. I want my GitHub Iron Man logo over here. Okay, so, right. So guys, you'll see on your laptops we've got two kinds of post-its, all right? That's to help us to interact with each other. Have anybody ever gone to a software carpentry event? No? Ever heard of software carpentry? No. Well, this is a trick that we learned from software carpentry. Instead of sticking up your hands and asking a question, and thereby interrupting whatever's going on, we ask you just to communicate visually with these two things, okay? So one, the orange one, is going to represent things that are good, all right? So you finished a task, or you understand something, or things like that. The other one is a bad, okay? So the pink one is for when things go wrong, and that maybe you haven't finished a task, you've got some kind of problem, you need help, okay? And by doing that, we'll be able to see more or less where people are, and we can also surreptitiously send helpers to you so that we can solve your problem in the background, okay? So sometimes it'll turn out that people have, everyone has the same kind of problem, like you may have a problem logging into a place or finding a URL or on a piece of code or something like that. And then we'll stop the session and focus on that. But most of the time it would be cool if you could just leave the post-its off your laptop, and when we ask you, okay, now it's time to go do this thing. As soon as you're finished, you put on the orange one, and if you think you're having a problem, you put on the pink one. And it just helps us to know what's going on, okay? Might take a bit of time to get used to that, so let's do a quick trial. Take the post-its off your laptop, okay? And I'm going to ask you a question. As soon as you know the answer, put the right sticker on your laptop. So what's 4 plus 5? As soon as you know the right answer, put the orange sticker on your laptop. If you don't know what 4 plus 5 is, then put the pink sticker on your laptop. I don't see any stickers except for this one. There's another one. 4 plus 5 is the question. Oh my God. Have you been to school? Would you like me to say it in a different language? Okay. See, so as soon as I see there's a problem, I see Mario is having a problem, he can't hear me. I see Rita's having a problem, so we're going to send people over there and help them. And that's just how it works, okay? It's just a way to keep us flowing, make sure that we don't get stuck by questions, okay? Obviously, if you do have a question, it's very valid to ask that, but just signal your question with a pink slip, okay? Someone will come around, or maybe if you think that it has something to do immediately, you can stick up your hand. We would like to avoid getting stuck, all right? Most of the time in these 2 weeks, we want to be writing code. And so we don't want to, that takes a lot of concentration, it takes a lot of effort, and we don't want to interrupt that kind of thing, okay? So that's basically all I have to say. There's a couple of things which I think can help us. Methodologies of working. Like I said, most of the time we hope that people will be writing code, and that at the end of the project, or this 2 weeks, you'll have some kind of a product, some piece of software that's going to work. And to do that, we need to collaborate with each other. So it'd be really cool if everybody gets to know each other's name, where they're from, what their expertise is. We've got the breaks to do that, and obviously, be as flexible as you like. But there's also some things that you can do to your project to help that along. And that is obviously to have a GitHub repository. That is to include in the GitHub repository a couple of things which tell people how to collaborate with you. So a way to contribute, a README, the things that are missing, so a roadmap, a milestone, that kind of thing, okay? I'll show something about that in the beginning of the day tomorrow, just to give you a quick get started on that. And that methodology comes to us from Mozilla, Mozilla Science Foundation. They kind of perfected that kind of thing, okay? So yeah, if you have any thoughts or comments about that, think about it. Interacting with us during the course, there's not like a wiki or anything. We just ask you to write the discussion topics on the Sci-GaIA forum. Okay, so it's federated login. You can log in the same way you log in with every other service. And if you have a question or something that needs to be discussed online or offline, we can take it there. Okay, so take your post-its off, please. And the task that you have in front of you now is to go to the forum just to see it. Okay, it's discourse.scigaia.eu. And when you've got the forum in front of you, just put the orange sticker on, so we can have another practice run, okay? So again, your task is just to see that URL. Once you see it, stick up the orange sticker on your laptop. Just stick it on your laptop. You don't have to, otherwise you only got one hand to work with, and that's no good. If you have problems with the network, or if you don't find the URL, obviously use the pink sticker. Okay, and that's just how we would like to roll in this week. There's no hard and fast rules, obviously, and I don't see an orange stick over here. Have you found it?
I didn't get the instruction.
Okay, so you need to go to discourse.sci-GaIA.eu. Yeah. Discourse, D-I-S. Yeah. C-O-U-R-S-E. Discourse. Okay. Dot. Yes. Okay. All right. Lots of orange stickers. So we got an orange sticker. Missing an orange sticker on that side. You good? Have you got an orange sticker or no sticker? No. Okay. Can you see the website? Okay. Then stick up an orange sticker. So I know that you have completed the task. Okay. Right. Do it in the back. Okay. So I'm done. We can move on to Ricardo, right?
Yes.
Okay.
Just logistic information. I mean, if you need to sketch something, all these blackboards are available. So starting from Wednesday or Thursday, we will leave out all the screens, and you can sketch whatever you want on the blackboard. There's a lot of chalk there, or you can use the whiteboard. If you have burning problems, or you can leave just comments or problems, use one of the stickers, write something, and stick on the whiteboard. And then we will collect the post-its, and then we will analyze your problem. So this yellow pink is to say, okay, I understood, I didn't understand, but otherwise you can just write something and it will stick. In the course of the days, before everybody leaves, we will briefly interview each of you. So we will ask you just a few questions, and then we will shut the video, okay? Because we will create a gallery of each of you participating, who you are, where are you coming from, and so on, okay? So just a few questions that we will ask you on the video. And this will help us to make a final video of the entire Hackfest. Okay, so now we can move to the first technical presentation. Ricardo will talk about the future gateway. Ricardo, you should tell us when you leave the presentation to run the end zone, because we need to record your screen from the back. Okay? So when you stop presenting and you will run playing something, you will tell us.
On the third slide.
Okay. The floor is yours.
So from now on, we'll introduce you to the future gateway, one component to provide user interfaces for final users. And this presentation is split in three PowerPoint slides. The first, the one I'm going to introduce now, is just an overview of the system. Then we will go deep inside to the API exposed by this environment. And the third slide is the one containing a little practice section that me and my colleague Mario will show you afterwards. So here you are, the outline of the topics covered by this first set of slides showing the overview of the future gateway. And what is the future gateway? The future gateway is a framework that is that aims to create science gateways. I don't know if any of you knows or heard about future gateways before. A science gateway is there exists a definition given by the TerraGrid ex-sede. It's a community-developed set of tools, applications, and data, normally integrated via a portal or a suite of applications, providing a user interface, and further customized to meet a specific scientific need. So from this definition, we can see some words highlighted here. So the Science Gateway is meant to serve a community. It is talking about applications, tools, some cooperative means, and of course provide a graphical user interface to serve such community. The Future Gateway itself is not a really new product. It's an evolution of another existing framework that maybe some of you could know, and that is the Catania Science Gateway framework. The most important target that Future Gateway is trying to reach is to improve the weakness identified from this earlier system. For instance, we tried to provide an easy mechanism to install the environment or maintain this environment over time. So for instance, we have the possibility to install the Future Gateway with installation scripts. You can also participate to coding of this component just because all source codes are on GitHub. And its architecture is thought to be easily customizable. This because, as you remember in the Science Gateway definition, it is important to meet community needs, while providing a Science Gateway. It also provides flexible and uniform access to distributed computing services. And this is accomplished by mainly by the J-Saga library. Saga is a standard created to target distributed application on distributed infrastructure. And but this with the Future Gateway, there are defined the so-called executor interfaces. So we are providing a way to customize the standard behavior of the Future Gateway accordingly to the specific targeted distributed infrastructure that you may have. Another point is that we are providing a solution that is totally portal independent. What does means? In the Catania Science Gateway framework, we were proposing a specific portal technology, and but normally communities may have already a portal serving already their science, and in such with the Future Gateway, you don't need anymore to use our suggested portal solution. We also concentrated to give a solution to make the development of application as easy as possible. This is accomplished by adopting the RESTful API solution. And we know maybe already that REST APIs are very important to develop quite easily any kind of network application. So on this slide, we can see the two different approaches. The one on the left is the classic Catania Science Gateway framework approach. We can see inside the big box is the LifeRay portal technology proposed at that time under this under this portlet, under this portal, we have different portlets. Portlets are the graphic user interface for the portal users, providing application interfaces, ways to move or deal with user files. And portlets are linked to the so-called grid engine. The real name of this component is the Grid and Cloud engine. Is an internal engine that is in charge to interact with the distributed infrastructures, so to physically access on behalf of the user to the physical infrastructure. And the grid engine will use this old name because you will see it in the source codes or in the configuration parameters. So the grid engine was tightly linked with GaIA. And GaIA is a Java library in charge to physically access to the distributed infrastructure. On the right side, you can see the differences with the Catania Science Gateway framework and the Future Gateway. So portlet, in this case, are not anymore linked with the grid engine directly, but they are only using REST APIs. And REST APIs are pointing to the so-called API server that you can see highlighted in the red box, in the bordered red box. The API server is then contacting the grid engine in order to execute user requests on the distributed infrastructure. But the API server has a modular shape. It can also interact with any other Saga implementation, for instance, or any other module in order to target the distributed infrastructure. This can be seen better here. We have under the zooming inside the API server box, we have two components. We have on top the API server front end, that is a system that is in charge to get the user's API. The front end is just filling a queue that is stored on a database table. And then we have the second component, the API server daemon, that polls over this database table and executes any user request, processing the record inserted by the front end. During the processing of the queue entries, the API server is instructed to target the specific executor. So one record may require to ask a job submission to the grid engine, or it can involve other modules. For instance, in the box, in the slide, we have that simple task that is another executor interface that will be shown later. Another architecture view is this one. We have on the left side the mobile and web applications communicating with the API front end through the REST APIs. The front end is communicating, is exchanging queue through the queue information with the API server daemon. The API server daemon is just polling on the queue table. You can see the task queue, in the yellow box, the task queue table. The API server is interacting with the specific target executor, so for instance the grid engine, the simple task, or even other. The grid engine interface is communicating with, of course, the grid engine. The grid engine will communicate with JSAGA. JSAGA itself is using other components named the adapters that are in charge to interact with the distributed infrastructure. With other interfaces, you can target any kind of other middleware, APIs. For instance, you can use Python Saga, or you can even target a command line execution. So this is totally independent from the API point of view. So this should target as much as possible the flexibility of the future gateway in respect with the previous architecture provided by the Catania Science Gateway framework. So we have the future gateway is component by those two important components. We have the API front end that in the source codes is identified as FG API server. It's a Python code using the Flask micro framework. This choice has been the choice to use Flask has been taken because this Flask framework is providing a very friendly way to expose API, RESTful APIs, and it is also very easy to customize the API behavior. The front end is contacting MySQL database, and this database is not only dealing with the queue, but it also provides information about application of the Science Gateway, parameters of the application provided by the Science Gateway, information about application input and output files, and then tasks, information about tasks that are submitted applications, and of course at the end the queue. The second component is the API server daemon. It's a Java servlet, and it's a daemon that it executes on Tomcat as application as a web application. This daemon is timely polling over the task queue, and it is responsible to implement the request provided by the user with the API, with the REST API. So at the moment, the API server is capable just to target the grid and cloud engine interface. So we can, for instance, with this component, we can send jobs on standard grid environment, G-Lite MEI, for instance. But it also provides a way to submit jobs via SSH. tasks and also users that are using the APIs, and of course there are also defined groups and roles for each group. The second component is a servlet that is running as a daemon. This component is written in Java because, for instance, use J-Saga as a component. J-Saga is written in Java, and so the best way was to target the J-Saga libraries using Java code. The daemon is polling the task queue, and as soon as one command is inside the queue, the daemon process flag it as in processing, and will target the specific executor interface to run the command. There is also another task performed by the API server daemon. It's a really simple mechanism to check timely the executed commands. There is a very simple mechanism to retry failed requests, and as soon as the number of failed requests reaches a threshold, then will be marked as failed and reported to the administrator. The daemon is also providing a kind of control panel. This is not really mature, and at the moment is just providing configuration information. This part needs further developments. So maybe it's better to spend a few time on this slide, because in this slide we have the typical usage of the future gateway taught so far. So we have on top of the final user, and the final user can exploit APIs with the LifeRay portal and its portlets. You can see the green box on the left. And this first approach is the typical approach provided by the Catania Sense Gateway framework. In the middle, the final user can deal directly with a community, a generic kind of community portal. So inside that portal, it is possible to develop a web application portlet or any kind of web plus Ajax call. It is possible to communicate with the API server, front-end and daemon. And the other possible way to use the APIs provided by the Future Gateway is by mobile or desktop applications. In such a case, you may be linked with an existing portal. You can see those gray lines linking a portal with a mobile desktop application, or you can directly contact the API server, front-end and daemon. So how final users can interact with the APIs, with the REST APIs. Let's start from how the Catania Sense Gateway framework was managing the authentication and the authorization, and then we will see the differences with the Future Gateway. So we have on the left the user that is contacting the portal, is connecting to the portal. The portal provides the identity provider authentication authentication interface. So typically you are prompted to type your username and password. So the identity provider authenticates the user, and then the portal contact if the authentication is good. So the portal will contact an LDAP server in order to get the user authorization records. Then the user can, the portal will generate a token in order to contact the API server. So this is the way the Catania Science Gateway framework can be used as well to contact to use the API, the REST API calls provided by the API, by the Future Gateway. So in Indigo, you can see in the top of the slide there is the link of deliverable that explains this solution. We decided to use the portal, to link the user with the portal in order to be authenticated and authorized. The user connects to the portal. The portal provides again a login screen to the user. And as soon as the user is logged in successfully, we'll provide a token. This token is used by the Future Gateway with the services exposed by the portal. That is the red ball token check. The token check verifies if the token is good or not, and if it is successful, send it to the Future Gateway, so to the REST engine. This is the same way to explain this mechanism. So the user contacts the Indigo EAM system. In Indigo, the authorization and the authentication component is named IAM. This component is returning the token. The token is sent from the portal to the API server. The API server checks the validity of this token for each REST call. And if the token is good, the API server will send this token to the resources, and the resources can be accessed or not accordingly to the authorization information contained in the token. So beside the Indigo mechanism and the way the Catania Science Gateway framework is managing the authentication and authorization, the Future Gateway is providing a baseline authorization and authentication mechanism. It's a very simple way thought for all those situations where users don't have any kind of authorization and authentication mechanism. So the principle is very simple. You have to share a common key between the component that is authenticating the user and the API server. There is a special configuration parameter for that. So the user first has to authenticate. The key encrypts the username, password, and timestamp information of this so-called this information inside the so-called log token. And the log token is sent to a special API entry point to the API server front end. The log token is analyzed by the server, identifies a registered user inside the API server, and a session token will be generated if the user is successfully mapped. This session token will be used later to interact with any further REST call. So at the moment, the future gateway has been implemented in several situations. At the beginning, in November of last year, it has been presented on the AGI Community Forum with a demonstrative portal. So I developed the so-called Hello World application that was using the Grid and Cloud engine and with its SSH adapter to send a simple Hello World job. And another more complex portlet called NS, providing a complex user interface and again executing something on via SSH with the Grid and Cloud engine. Later in February, during the Cloudscape conference in Brussels, we demonstrated two Indigo use cases. The first called molecular dynamics. This was using again the Grid and Cloud engine, using its ROCCI JSAG adapter. So we had a Docker container providing all the software for this molecular dynamics. The Future Gateway APIs were capable to instantiate the VM according to an input, execute the molecular dynamic case, and retrieve back the results of this execution. And the second demonstration was the so-called climate change. This use case will be shown by next presentations, so we'll not spend so much words here. By the way, it's using again the Grid and Cloud engine. It is using its SSH adapter to execute something on virtual machine. But in this case, execution requests are piloted by the so-called Kepler, that is a workflow management system. So after this presentation in Cloudscape, a further development has been done with the molecular dynamics case when we started to use Indigo services through the Tosca adapter. We developed its first implementation and we called it Simple Tosca. And Simple Tosca just requires a YAML file containing the description of what you are requesting. So in this case, the Docker instance, the Docker container containing all the software components. And we were successfully demonstrating also that was possible to target with the Future Gateway also the Tosca orchestrator component coming from Indigo experience. So just to have a look on what is going inside those, for instance, in molecular dynamics, we have an external a community portal on top of this slide, the Amber Web GUI. This user interface is exploiting the Future Gateway REST APIs. The Future Gateway takes the request, contacts the grid engine. The grid engine is exploiting the JSAGA library. JSAGA library is contacting the adapter, in this case the ROCCI. The adapter is contacting the OpenStack instance. The OpenStack is opening the molecular dynamic container, and then via the SSH, still piloted by the ROCCI adapter, is executing the molecular dynamic job. And then the I/O staging component of the JSAGA is again providing back the results to the grid engine interface. So it seems quite complicated. A lot of interaction are available here. But if you see, when I switched this situation with the new JSAGA adapter, you can see the difference very little, because the only thing that is changing is the Tosca component. Tosca component is behaving totally different, but from the API point of view, the situation doesn't change at all. So the calls remain the same, while what is happening under the hood is totally different. Sorry. I almost finished, sorry for... So Tosca, as Giacinto shown us before, Tosca is contacting the IAM. The IAM instantiates the container for us, and Tosca component is interacting with the SSH as soon as the container is available and execute the molecular dynamics job. So the Future Gateway is also providing some tools for development. All source code is available on GitHub. You can see the link. And it is possible to start developing on it just installing the Future Gateway. Installation scripts are available. You can install very easily on a standalone Ubuntu server 14.04 or inside still Ubuntu 14.04 Docker image. Or you can even use the AGI Fed Cloud infrastructure, and there exists an appliance for that. There are also facilities to update the software packages, keep aligned the database schema with the new software versions, and there are also some development tools to customize the code. I will show you also this in the very technical presentation. So this concludes the overview of the Future Gateway. So from now on, I will be more technical, and the next step will be to focus on the APIs provided by the RESTful calls. So if someone of you has questions, free to ask. Bruce, help me. Is it still here, Bruce? No, the meaning of the orange label was?
Everything is fine.
Okay, thank you. I was really concentrated on presentation. So no pink boxes. Yeah.
Could you tell us what's the difference between the virtual research environment, VRE, and scientific gateway?
The science gateway is the mean to reach the virtual resource. They are targeting, so it's the way to let the users address the virtual research infrastructure. So the intention is to give easy experience to the user to interact with the technicalities exposed by the research infrastructure. Roberto maybe wants to.
Well, there are lots of concepts. Science gateways, it's one of the components of a virtual research environment, actually. So a virtual research environment can have science gateways, but you can also have open access repositories. You can have other kind of resources. So a science gateway, I mean, if you need just to run applications, run your application, then the science gateway can be a virtual research environment. But if you also need to run application on data stored on open access repositories, then your virtual research environment is bigger than the science gateway alone.
Maybe I can add something to that. So it all comes down to functionality. So your VRE may have lots of different components that you pull in based on what your community wants, but that's got a specific set of functions which it can execute. So the Science Gateway, if your community only wants to execute applications or store data, and that API can do that, then it's the same thing. But usually that's not the case. So you actually want to expand the VRE into something that's very rich and diverse in terms of services. And so this is one of the components that you build a VRE out of.
So if there are no other questions, I can continue with the APIs. So we can focus on what the future gateway is exposing in terms of REST APIs.
Ricardo, excuse me. Wait a moment. Can you just show us the repo URL again, please, so we can get code?
Wait a moment, because I closed the file of the previous slides. If I remember well, here. Is it correct?
Yeah. Okay, so that's the organization. Which one is the repo? Which repository should we be looking at?
So
the API server, for example.
I can show you. Just a moment. I'm contacting the GitHub page, so I'm waiting. It seems very slow.
Because he is API server daemon, portal setup. There's one called API server, which I reckon is probably the right.
Yes, in this.
Bruce,
Yeah.
Ricardo's slides are all the others that will be presented today are on the agenda page.
Yes, I'm
So
also.
if you go to the agenda page, and you can download the slides, and you have everything.
Unfortunately, it's quite slow. I don't know why.
Well, never mind, carry on.
You try to get the link, if you just copy and paste the URL, that should probably get.
So this is okay. So this is the main place containing all soft packages related to the future gateway. So this is the front end. For instance, this is the daemon. Under portal setup, we have installation scripts. And here we are some tools used in the context of Indigo, but also to help developers to manage source code. Then we have the portlets, for instance, the NS portlet of the first demo. And the hello tester is another very simple portlet that is submitting something on the distributed infrastructures. So, and here you can see specification of the APIs, and this is a further development for the future gateway.
So does it mean that we cannot run this on Windows machine because you have implementation only on Ubuntu?
On Windows, let me think, because the front end, I don't know if it is possible, but maybe yes. I don't know if Flask works on Windows. But potentially it could be moved to Windows. But this is not supported by us. We are just thinking to use, of course, Ubuntu, but also scientific Linux, CentOS distributions. So enterprise Linux is based installations. And as well as Mac. I started to develop this environment on my laptop, so some of the scripts are also capable to install everything on a Mac. But on Windows, okay, potentially there is the possibility to run it. I'm not totally sure for the front-end part of the API server. But for the API server daemon, I think you can run it because it is running under Tomcat. It's a web application, so you shouldn't have problems. I don't know if Flask works because you have a Python and Windows, but Flask I don't know how it works. So potentially it should work, but I'm not sure about that. So. Of course, we are looking forward to have volunteers collaborating. Yeah, because I'm providing also installation scripts for Ubuntu, but I didn't have the time to change those existing scripts to automatically install for CentOS, for instance. So this would be really important for us. So if you enjoy to play with installation stuff, you can try with Windows, and we can try to support that platform too. So let's move on the APIs part. Let's skip the outline because we will see later. So let's start talking about the APIs from, of course, their specifications. They were defined in August 2015, more or less. The date is not really precise. And they were written in the API, I don't know how to pronounce exactly this website. So those the specifications are available on internet using the link specified in the slide. So the main aim of the Future Gateway APIs is to deal with the task management. We use the word task instead, for instance, of job. That is the common way to think about distributing when we are dealing with the distributing infrastructure. For instance, we send a job on a grid. In the case of Future Gateway, our intention was to provide a mechanism to not only send jobs, but also instantiate virtual machines, instantiate with Indigo, for instance, PAS, or execute a job inside a virtual machine. So this is a kind of generic mechanism was identified as a task. So in the naming convention of the Future Gateway, what we were thinking at the time of grids became tasks. So a task, we have, of course, API calls to manage tasks in the form of a collection. Sorry to interrupt you.
So whatever you call a task is an execution, right? It's got nothing to do with the management of data.
Also, it's not exactly, we are not still covering from a specification point of view the data management, but I'm expecting that with the task word will include as well as an operation involving with data. So a task could be a file copy. Or an action to download something. So could be translated also, could be. Then a task is linked with an application. That is the generic way to think, so the better way to explain so the task is an instance of an application, and an application needs information to execute on a physical infrastructure, and this kind of information is stored inside the infrastructure collection. Then in the future we will have also API calls to manage users, groups, and roles. So, as I told you, tasks are instances of applications, but application can define something that execute somewhere, but also could be something that is creating an infrastructure. So we have the way to specify this on the APIs. We have also we can have also the possibility to send or receive files from the distributed infrastructure. We can pass arguments in order to change the behavior of our submission. We can we have to define as well the technical parameters to interact correctly with the targeted distributed infrastructure. When we define an infrastructure, normally we use a set of pairs defining a key value and its value. And for instance, when we define JSAG adapter settings, we use such a way. We will see, I will show during this slide how. Inside the infrastructure settings, we have also other special settings that are piloting other third-party components, for instance, the token server parameters. I will also show you later some details about this. So again, we can also manage groups and roles and users. So this is the classic way to explain the REST call in a generic fashion. So we have the protocol name the left, HTTP or HTTPS, accordingly to the configuration given in the front end. Then you have to provide the host name and port where the front end is listening to. Then you have to provide the version of the APIs, in this case version 1.0. Then which kind of action you want to ask, and optionally a set of parameter values. So this is the generic way you interact with the Future Gateway APIs. The supported methods implemented in the front end are involving the get, the post, the patch, and delete. Any input that you provide to the APIs will be in JSON format, and the output of any request will be JSON as well. And inside there is inside the JSON you will see also the underscore link field containing also the action that are related to the REST API call you issued. The REST calls are also in charge to deal with the token management, and this is accomplished with specifying it in the either section of the REST API. And you can also use as a filter the user field in order to specify a different username. So this is useful, for instance, for a user to operate on behalf of some other user. Some convention used by those slides. So all examples I'm going to provide you now are exploiting the curl command. It's a very powerful tool in order to explain APIs. I'm not using this tool as a JQ on those slides, but this is a very useful field to filter JSON outputs. So you maybe write scripts that are using this tool to filter out, for instance, the application ID from an answer or the job status, the task status during execution. All those examples I'm going to show will not use tokens. I will just explain the token management on concentrating everything in just one slide. So in case the token management is switched off, because you can specify this behavior configuring the front end, in this case you configure also in the configuration file which is the default user that will be used by the Future Gateway. So the first, before to start with the API, I will introduce briefly some database table used by the API server. So on top you can see the application table. The application table contains generic information about the installed application for the Feature Gateway. Each application has application file table specifying which files are using the application, the parameters piloting the behavior of the application, and the infrastructure that are specifying the technical details to interact to a specific distributed infrastructure. An application instance is a task. So as soon as a user submit a task, the task, a record will be created in this table. The task contains information about the provided arguments, input files, output files, and this table, runtime data, is a way that a task can share information with the user. So, for instance, a task that is creating a virtual machine can exploit this runtime data to publish the IP address of that virtual machine to the user. This is just one simple example I can do. And finally, we have the queue table that is processed by the API server daemon component. This is explaining the fields related to the application and the application-related tables. I don't want to go in detail here. So you can watch these slides later on. This is the schema, the links between task and task tables. And finally, we have the table, the queue table, linking the task. Then we have information about the target identifier. For instance, if it is a grid job, you have a reference to that grid job from this ID. So the status of the feature gateway, of the APIs, the really status on the target, and then some information about the timestamp of the last change, when the task has been enqueued, etc. So let's start our API explanation, starting from tasks. So in order to show the list of all tasks, you can use this call. So for instance, you can use pur http host port version and then the word tasks. This will return a JSON containing a field tasks and inside a vector with the task description. So we have information about the submission date, which is the last update of the status, timestamp, the list of input files, output files, which is the application related to the task, arguments eventually provided while submitting the task, the section related to the runtime data, so when this data has been created, changed, the name of the field, the value of the field, and also a description is if it's available. And at the bottom you have the links section explaining the action you can do after the task operation. You can use filters, for instance, for get the tasks of a specific user. So in such a case, you specify the filter user equal and then the name of the user you want to monitor the tasks. Or you can even you can be even more specific. You can specify, for instance, a user, and specify also the identifier of the application. So, for instance, I want to see how many submissions of molecular dynamics application have been performed by a guy, by a specific user. So normally, if the user is not specifying user name here in the filter, a default username will be used. So if you are using tokens, the user associated to the token will be used. If the token management is switched off, a default user is specified in the configuration file of the front end, of the API server front end. Together with the tasks, you can focus on a specific task. So you can get information of a specific task, just providing this entry point, tasks, and then the ID number of the specific task. And you again get a JSON output containing the same information I showed you before, but in this, so just one entry of this array. In order to submit a task, you still use the entry point tasks, but you have to specify as a JSON and sending as a post request the following data content. This is an example, the most simple example I can provide you. So I want to execute the application 3, and I can provide just a description of this submission, and this is enough to submit something with the REST APIs. When you submit a task, you can get two different kind of answers. You can get the descriptive a JSON containing the description of the task, and the state, and inside the status you are notified that the task has been enqueued. Or you can get again the information about the task, but the task is not really executed. Okay. And in this case, in this second case, the task is waiting for further inputs from the user. So the user has still to specify input files to finalize the task request. In such a case, you have to specify input files with other curl commands, for instance, like this. So the entry point is still tasks. You specify the task ID of your submission, and then as post data, you can provide any input file you want with the -f for curl, for instance, input file with the path, the full path of the file, -f, etc., the second file name, and then input. If you don't want to, you don't have any input file, but the job is waiting for input for the user to finalize the task execution, you can send the post request without specifying any input file. So this behavior is more complicated to explain during the practice, much more easy to.
Sorry to bump in.
There are two cases. The task, because I will explain this mechanism later also. So you send the first command, and you are asking to submit something. There are two possibilities. The task starts immediately, and this depends on the configuration of the application. So the other case is that the task is not immediately executed, but is waiting to be confirmed. So you have to provide some input files for execute that task. So there is the possibility that you really want to provide files, but there are possibilities where you accept the default configuration of that application. So the configuration of the application contains default files. So in such a case, you use the first format, so the post call to input, without providing any input file. If you really want to send your own files, you use this second syntax. But both are executing for real, so they are triggering the execution of the task. So how can I get the output of the task? If you use the get method to get the list of the tasks or the detail of a specific task, inside the fields, inside the JSON, you have the field output files. In this slide, there is an example. Output files contains records like an URL, entry point, and a name. So in order to get the output of this file, of this specific file, you have to select this URL path and place it inside creating this new entry point for API server. So you can get the content, so you can download this file just providing this command. So just moving the information inside, contained inside the URL from version 1 till here. In order to delete a task, you can use the delete method, the REST method delete, providing the task ID of the task you want to delete. This command totally removes any reference of this task execution from database, file system, etc. So this really cleans everything. So no, if it is running, it should fail.
You should not allow delete.
Yeah, exactly.
Okay.
But I don't know if this mechanism is, this behavior is foreseen. Maybe you are getting unexpected behaviors, because I think I don't place any check for that. Or maybe I developed this a lot of time ago, so maybe there is a check on the status, and I will check this. I will keep note.
Normally,
Exactly.
normally you shouldn't be able to delete a job that has started.
Yes.
What you could do is to kill the job using the call as primary kill.
Exactly.
Which will go to or Linux command. So you can kill the job rather than just delete it. After it's been killed, then you should be able to clean it.
I think the kill does not exist in the specifications.
Okay, this one.
So the concept of killing something, I think, is not foreseen yet.
Okay.
I think tomorrow.
Maybe tomorrow you will.
So next APIs will be related to the applications. Because before to go to the API itself, let's analyze some tables. For instance, the application parameters. Inside the application parameter table, normally we use to specify which is the executable. There is a field missing here. I'm remembering that really now. There is also a field that specifies if this application is creating a job or if this application is related to the creation of an infrastructure. This is a field that is missing here. Then I'm collecting on this table the arguments provided to provide to the application, which are the output files, which will be the output file, so something execute on somewhere. You have the console output of this execution, and this output is specified by this parameter. The same thing for the error file. And then another important field is the target executor. So this is specifying in the Q table which will be the executor interface in charge of consume this application. So if I want to use the grid engine, I have to specify the word grid engine on that parameter. If I want to use Tosca, I have to use I have to type simple Tosca inside this field. I think there are examples also for this. So this table is quite important to understand the mechanism, because it is the table responsible of the different behavior of during the task submission. So normally application shouldn't need to specify an input file. By the way, there are many cases where application have a default set of input files to provide. So in order to help developers or help users to have much lighter task submission command lines, there is this table where you can specify which are the default input files for a specific application. Here there is a simple example. For instance, there exists an application that has the default Tosca template YAML file describing the resources to be created by the orchestrator, and the second file is the shell script that will be executed inside the created resource. So those files never changes, because those are not changeable normally by the user. There is no need that the user specify each time those commands, those files. So in this way you can specify default input files. And you provide the name and the location where the file is located. Then there is this flag override, and the meaning is, okay, I have default files, but I want to give, but the user, using the command line, can specify its own file. So a malicious user could send another shell script that will do bad things on the remote infrastructure. If I want to avoid this possibility for the user, I can switch this flag to 1. So this file overrides totally the intention of the user. So the user, if the user specifies these input files, normally will be overwritten. But if you specify that flag as true, the user cannot change what is specified in this table. So for instance, if you specify both files having the override flag true, and you send the request to submit the task will start immediately. So will behave in the, you issue the first call. Do you remember the post call to submit a task? So you issue this command, and the task will start immediately. If the flags are 0 or false, the task will wait that the user submit the files. If the user sends this second call to finalize the task submission, the files specified in the table will be used. Otherwise, if the user specify a specific file here with the -f option, etc., the files specified by the user will be used instead of the default ones.
Can the JSON, I know you've mentioned that the input and output must be JSON. Can it be so or any other thing?
Sorry.
You know the JSON, the input and output file, if you are specified there that it should be JSON file. JSON,
No, not for this. JSON output are for input you provide to the REST APIs, and JSON will be the output of the API call. So files can be any kind of file.
it can be any other.
Yeah, yeah.
Okay. Thank you.
Okay, after the application file, we can have a look on the configuration to target a specific infrastructure. And the following slides are showing what happens for to configure SSH or CCI, WMS, or Tosca. Let's start from the most simple one. You have this is the table that specifies the infrastructure parameters. In the infrastructure parameter, you specify which is the JSAGA job service. Sorry. And in this case, we are specifying that you want to target SSH, which is the host name of the SSH that is listening to, and the port of SSH, the username, and the password. So this is really the most easy configurable way to execute something with the future gateway APIs. A more complex configuration is here, defining ROCCI entry point for JSAGA. I remember OCCI is a protocol to start up a virtual machine using a standard protocol. OCCI installs for you the virtual machine, and then this adapter is able to submit something inside this virtual machine and retrieve the output back. So in order to do this, you have to specify which is the entry point of OCCI, listening for OCCI calls, which kind of resource you want to instantiate, which kind of physical resource will have the virtual appliance, then the name of the virtual machine, And then you can see here a set of calls specifying the credential needed by the OCCI entry point to execute, to instantiate the virtual machine. So the credentials are coming from a third-party service called the eToken server, and these are the necessary configuration value to instruct this service. Then there exists also the possibility to specify further parameters in the job service row. And here there is a little example. So of course the host, the port, but you can also specify other options here, but I don't want to go in details now about this. So, for instance, how much shall I wait before to raise an exception that the virtual appliance has not been created in time, the name of the virtual appliance, etc. To whom is more practice with the grid environment, again, we have here the entry point of the WMS against which I want to execute a job. The LDAP parameters specifying, and then again the robot proxy certificate details. So the configuration values to get a robot proxy certificate that will be right to execute this job. In Tosca, the scenario is simple as well. You have to specify the entry point of the orchestrator. The entry point normally terminates with deployments. In the future, you have, but I think now development people developing the orchestrator requires the token. So the token will be written here. Then, which will be the YAML file describing the Tosca resource, and the other parameters related to the creation of the resource. So how much time I have to wait before raise an exception, etc., etc. We can now watch the APIs related to the application management. So of course we can list applications, just providing the entry point applications. So we'll get the full list of applications installed on the Future Gateway. We have all details in the returned JSON. We can get the details of a specific application, continuing the entry point with the application ID. In order to create an application, exactly like you do with the task submission, you specify a post data, a JSON content that is specifying the details of the application. There is an example on the next slide. To delete an application, again, you have to specify the action that must be deleted and the application ID. So the entry point is applications, application ID. This is a JSON, a very simple JSON explaining how I define an application in order to be installed on the Future Gateway. This is the field that specifies if the application is a job or infrastructure. Then the description, what does the application, the name of the application. You can switch off this application So if you switch off this application, nobody will be able to create a task related to this application. And then application parameters, so the target executor in this case, which is the executable, the output file, the error file. Then there is the section specifying the infrastructure. So we have an array with the many infrastructure available. Each infrastructure will have their own, its own parameters. So in the case of SSH, I can provide here the entry point, the username, and the password. So this is the post data, and this is the entry point. Again, application. So till now, the token management has not covered. And next slides we'll talk about the token management. So let's start with the baseline token management provided by the baseline installation. So if I don't want to use Indigo Way, if I don't want to use the Catania Science Gateway framework authentication and authorization, I don't have nothing on my site. I want just to, at least also for testing purposes. So this is the mechanism provided by the baseline. We are already seen this slide, the overview. So the first thing to do is to reach this out entry point, specifying in the header section this string, authorization, comma, column, bearer, and then a log token. This value, this log token, has to be created using the key configured on the API server front end. So there exists on the source codes a little Python code called mk log token that helps you to create such a log token. So in the code of this little script can be used for instance, to generate those log tokens from a web interface on the portal. So once you get the section token from this call, you can use any kind of REST API specifying in the header authorization, column, and the session token. There is another way to get a session token. You can even use out, providing in the parameters the username and the password. In such a case, it's highly suggested to use HTTPS protocol, because username and password are coming in the stream. So this is another possibility you may have. This is for what concerns the baseline setting. In Indigo, this mechanism is totally unused. The mechanism, as I told you, is that the user connects to the portal provides the authentication and authorization interface. From authorization and authentication, I get only a token. The token will be used to contact the API server, and the API server will check each incoming token with the portal. So this arrow is wrong. Sorry. I will update the slide later. because the portal is providing an entry point where I can check the token. Then the token will be used to access or not to the resources. So in order to accomplish this, there is a feature in the configuration file named the portal token validator. And what you have to specify is in the configuration file is that you want this kind of authentication and authorization. And you have to provide which is the entry point that the portal provides you to check the validity of the tokens. So here you are kind of HTTP, HTTPS entry point. This entry point will require credentials, so a username and a password. And the answer of this check will be the portal username if the user is authenticated, authorized, the group the user belongs, but username and groups are an optional answer. The API server will use the information coming from this check to map the portal user with the users that are defined on the future gateway. So there is no, potentially there is no match one-to-one between API server user and portal users. Of course, you may have a configuration where you have a mapping one-to-one between portal users and API server users. So this is very useful, for instance, when you want to group portal users. For instance, the portal serves biomedics and biomedics users and another discipline-based community, and you want to group memberships in those two groups. Then, of course, the application defined on the API server, there are applications serving the one community and applications serving another community, so grouping with two different users, with the two different groups in the API server, you can have just two users here in API server serving two communities in the portal. So in order to specify which will be the mapping between the portal and the API server, there exists in the installation this FG API server underscore PTV map. It's a JSON file that specifies the rules that will map the portal user with the API server, the future gateway users. Those are some roles available. So for instance, a user can install application or can do changes on the application definition. Users can or not delete application, view application details, and such kind of operations. The roles are normally applied to groups so that and users are linked to groups. So in order to use API, till now we have seen curl commands. Of course, web pages are not using curl. On our experiences, on our examples, till now we used Ajax to provide to execute API calls, and live ray portlets. Of course, the use of REST APIs opens to any kind of language or any kind of web technology. And as you have seen before, sometimes infrastructure requires credential in form of proxy certificates, and in such a cases we are using a third-party service named eToken server. And if you need this, it's necessary to open a VPN section between your future gateway instance and this third-party service, eToken server. Or you have to open your IP address or your future gateway IP address against the firewall in the eToken server service. But this is really a detail now. This is the way to call API server using Ajax, for instance. You can see this kind of example in GitHub. I use this for Hello Tester. In the case of portlets, we are supporting by the installation script LifeRay 6.2 and LifeRay 7. And in this slide you have described the steps to generate the portlet code from the SDK. And in case of LifeRay 7, this method is totally different, and you have here a documentation link pointing to the instruction on how to develop with LifeRay. Again, information about VPN, but this is in case you want to develop an application and you need proxy certificates, then you have to request us the access to this eToken service. And there are links, emails, our emails in order to get the access to this VPN service that helps you to connect to the eToken server service. So this concludes the API section. So I don't know if someone of you has questions or not.
Questions for this? Okay. So since it's already 1 o'clock, I would suggest you to break here, to go for lunch. We reconvene in 1 hour. We briefly go through the practical, and then we move to Marika for the PAAS.
Yes.
Otherwise, we'll go to lunch too late.
Exactly, yeah, it's okay.
Okay? So,
I think
here.
the practical section will be really short. It's not.
Okay. Okay. So, lunch instructions. We have to cross the football field, which is just here, and then we have to go to the canteen altogether because there is a list of people that it's already subscribed. If some of you, because I got the late confirmations, if some of you is not in the list, I'll take note and I will ask people to add.
Depending on where you go, it's the same thing today.
Allora io devo prendere mi serve un altro foglio di carta, lo prendo là. Sì, ma bisogna dire di chiudere. Io devo andare là, alla mensa, perché c'è una lista del
Yeah, something.
Guarda lei, guarda.
Quando lo preso, io ti insegno, dove sono tu mi insegni questo. No.